Okay. Let's explain the bit depths, okay? So, what we have is we have a audio file, right? The way the audio file is saved. Imagine you have a wave, right? And the wave is going like this. This is like the original wave, right? So we're gonna do this, right? And then like it's essentially just an audio file, right, with a wave. Okay, this is our audio file. It's just like 0.3 seconds long, okay? What happens is that your computer somehow has to decide what is what, right? Of course. So this is 0. And what it does is it breaks up this whole thing into small little pieces, right? So instead of having a continuous... Oh god, I can't zoom in more. No, I broke it. Instead of having this in a continuous line, what it does is it samples every so often, right? And for the sake of demonstration, I'm going to make these steps pretty big. Imagine it samples like here, right? So this is the sample rate. Usually this will sample 44.1 thousand times per second, right? So this is like way more thinner. It's like very, very, very fast. 2 times as fast as you can hear, right? So there's a lot of resolution. But essentially what it does is it checks and it does, okay, right here, I'm here, right here, I'm here, right here, I'm here, right? And it basically checks what the volume is of the actual audio file. And the issue with the whole thing is that at the end, what it does is it combines them, right? So it draws a line. Okay, I can't do it like this. It draws a line like this. And then it draws another line like this, right? And then it draws another line like this. So as you can see, you're already losing some of the resolution just by the way that the audio file is sampling your lines, right? So this is the first loss that you get. This is inherent because this is just how computers like treat audio, right? So you can see you're already losing some resolution, but this is usually not so crazy. Now, the next thing is that your computer actually doesn't play this line as is, but it has a sample and hold. Sample and hold is, it doesn't know how to draw like lines at an angle. So what it does is it always draws straight lines, right? So the next like loss of quality is you go always like this, right? And then from there, you go straight line across like this. And then from there, you go straight line across from this. And then you go straight line across from this because your computer doesn't know how to do anything else but a straight line from sample to sample. I'm trying to make this very comprehensive, okay? So that everybody understands where we're at. And the problem with this is now it has to combine these, right? And what it does is just steps. So you get just like this very bit crushy kind of sound. Now this happens at a very small scale, so you usually can't hear it, but it is there, right? Okay. So now what we want to do, right? We want to tell the computer which values to hold. And the way this is stored, right? If we look at this, let's say we look at this point. That's the wrong way around, arrow. Right, let's just look at this arrow, at this thing. What happens is we tell the computer, look, I have 2 things. I have, like, basically we want to give it an X and a Y coordinate, right? So the X and the Y essentially mean the X distance from here to here, right? That is going to be our X. And then the distance from here to here is going to be our Y, or like, let's say, I don't know where it is, but I think this is the distance. This is going to be our Y, right? And we're going to store the data of where this point is so that later on the computer can tell, right? So we're going to do, okay, X is at 0.225 and Y is at 0.57, right? I don't know, whatever, right? This is essentially what we're saying. Now, the problem with the whole thing is how much precision do we give this whole thing, right? You can imagine if we remove 1 decimal point, right? This becomes quite quantized, right? Like this is going to snap to essentially a very big grid. But if we give this like a lot of decimal points, right, this is going to become more accurate. It's going to be more close to the actual like wave that we had, right? So the more floating point values that we give it, right, the more precision we're going to get of the representation of what we originally had as the audio. And essentially, the bits control how many decimal points we get, right? So if we have, it's not exactly correct, okay? But I'm just gonna pretend that this is it's a simplification, okay? But still, essentially what we get is from here to here. Oh god, this is very thick. Okay, from here to here, right? This is the resolution of a 16-bit wave file. But from here to all the way at the end is 32-bit, right? So you can see how this value here at the end gives us more precision only in a 32-bit wave file and not in a 16 one, because we actually lose some of the like floating point values. Now, per default, wave bit integers can only go from 0 to 1. Yeah? What happens if we need to draw a point up here? Because we went over 0 dB when we rendered out, right? We clipped. What happens? This cannot draw it because there's no higher value than 1, right? So this will just be on 1 the whole time. So what's going to happen is it's going to draw this, and it's going to hit the ceiling, and it's just going to clip, 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 clip. What we can do, though, we can go to 32-bit float. Now, this is where the magic happens, because in a floating point system, right, which I'm going to make red. No, I'm going to draw red. Yes, we have 32-bit plus float. It means we can actually go above 1, right? So we can have 3, and we can have 55. Actually, why doesn't this makes no sense? But essentially, we can have higher values here that are above 1. Okay, so we can draw values that are higher up here. Essentially, however far up we want. The only issue that we get is if we only have this many numbers. So if we make this very, very loud, we need to remove some of the decimal points, right? So again, we're losing precision, but we can make it as loud as we want, right? So this comma just has to move. Yeah, so this is the 32-bit float. So this is only wave files though, because now what happens is, imagine you get a list, right? You get a list of all of these points, right? Your computer basically saves all of these points so that another computer can replay all the points. And you get a list of a bunch of different X and Y coordinates, right? You get a bunch, and they're all like for different points on the waveform. Right? So if we were to draw this, we can say, okay, this one is for this point. Okay, maybe I should make this red. No, not red. White. Right? So this one is for this point. And then, why is this here? Okay. And then this one is for this point. Oh God, why doesn't it work? Okay, and then you know what I mean, right? And this one is for this point. And so on. And at the end, we have this massive list of numbers. And there are algorithms that can make this smaller, right? So let's say at the end, when we have this massive file all combined, right? This is our WAV file now. This is our WAV file, and the WAV file has, I don't know how much. Let's say this is a WAV file. It didn't do any compression, and it has, let's say, 32 megabytes of size, right? Then we say, well, we can take the same thing and we can do some magic, and we can compress this. Compress into MP3, which does some magic so that the file size is smaller, and what we get is we get an MP3 that is now only 1.6 megabytes. Right? So we save file storage. But what this essentially does is it removes part of this again, right? So in an MP3 file, it's not exactly what happens, right? Compression works differently, but essentially what it does, it's like, well, if we just store less of this data, our size is going to be smaller, right? So we can essentially store more of these with less precision, so we lose some of the quality, but we can store more values with less space, right? And there's some other stuff that happens. So at the end, we get some loss in the quality, but we get a smaller file size, right? But this has nothing to do with the clipping. Clipping only has to do with 32-bit float or non-float values in WAV files. Okay. Now nobody has any idea of anything, right? Is anybody still with me? I feel like I did such a fantastic job actually explaining this right now. Even though it's probably still complex to understand, I feel like this is the best fucking way I've ever explained it. And I'm really happy. So this is essentially what the difference is between WAV files, bit float, right? WAV files and non-bit float WAV files, and then also MP3s and WAV files. Yes, Gemstones, ask something. So it renders the same way essentially, but we can store how loud it actually is. Like still clips, but you can store the loudness. Yes, exactly. So if you were to play back a 32-bit float that goes above 0 on the playback side, right? So this is essentially encoding. So you take the actual production that you have and you make it a digital file. Afterwards, right, the user has to then take this file. It has to write all of these values again, right? And then what it actually does is it takes this value and it tells your speaker, listen, speaker, right? Let's make this is the speaker. It gives these values to the speaker and it's like, hey, look, I have these values. Can you play them, please? And then it's like, okay, I can play this. Boom. But then when it gets a louder value than 1, it just plays 1 because the actual physical speaker has voltages instead of values from 0 to 1. And voltage only goes on or off between 0 and 1. It can't actually go like louder than 1 because that's not how physical voltages work. So it's going to just default this to 1. That's why you're still going to get clipping. But in the file itself, technically you still have the information of a louder information. That's why in FL, you can hit normalize, and then what it does is just moves everything down so that the loudest point is a 1 and changes all the other values. All right, ladies and gents, but what the hell is that? Jesus Christ. Now I'm tired. Now let's play some marbles. All right. I do coachings, by the way. If you ever want to go more in detail with this shit, we've only ever scratched the surface. Coachings. All right.